Welcome to NAT. Network Address Translation for CCNA. NAT helps solve a big problem with IPv4. The IPv4 address space would have been completely consumed by the mid-1990s. The original design for the Internet required every organization to ask for, and receive, one or more registered classful IPv4 network numbers. Connecting to the Internet using only a registered network number, or several registered network numbers, worked well for a while. The main long-term solution to the IPv4 address scalability problem was to increase the size of the IP address. This one fact was the most compelling reason for the advent of IP version 6, IPv6. IPv6 can easily support every organization and individual on the planet. Many short-term solutions to the addressing problem were suggested, but 3 standards work together to solve the problem. 2 of the standards work closely together: Network Address Translation, NAT, and Private Addressing. The third standard, Classless Interdomain Routing, CIDR, allows ISPs to reduce the wasting of IPv4 addresses by assigning a company a subset of a network number rather than the entire network. CIDR is a global address assignment convention that defines how the Internet Assigned Numbers Authority, IANA, its member agencies, and ISPs should assign the globally unique IPv4 address space to individual organizations. CIDR has 2 main goals. First, CIDR defines a way to assign public IP addresses worldwide and to allow route summarization. IANA allocated all addresses that begin with 198 to one of the 5 regional Internet registries RIR, and that RIR assigned this entire range to one big ISP in that part of the world. The assignment of all addresses that begin with 198 to one ISP lets other ISPs use one route, a route for 198.0.0.08, to match all those addresses, forwarding packets for those addresses to ISP1. This one summary route will match packets sent to all addresses in the Class C IP networks that begin with 198. The second major CIDR feature allows RIRs and ISPs to reduce waste by assigning a subset of a classful network to a single customer. What are private addresses? Some computers might never be connected to the Internet. These computers' IP addresses could be duplicates of registered IP addresses in the Internet. When designing the IP addressing convention for a network not connected to the Internet, an organization could pick and use any network number it wants. When building a private network that will have no Internet connectivity, you can use IP network numbers called private internets, as defined in RFC 1918, Address Allocation for Private Internets. This RFC defines a set of networks that will never be assigned to any organization as a registered network number. Instead of using someone else's registered network numbers, you can use numbers in a range that are not used by anyone else in the public Internet. Any organization can use these network numbers. However, no organization is allowed to advertise these networks using a routing protocol on the Internet.
What are the 3 functions that extended the life of IPv4?
CIDR, assign more specific public IPv4 address blocks to companies than Class A, B, and C networks.
Aggregate routes to public IPv4 addresses based on Worldwide Address Allocation Plan. NAT, enable approximately 65,000 TCP/UDP sessions to be supported by a single public IPv4 address. Private networks, enable the use of NAT for enterprise Internet connections, with private addresses used inside the enterprise.
Network Address Translation Concepts. NAT allows a host that does not have a valid, registered, globally unique IP address to communicate with other hosts through the Internet. The NAT function changes the private IP addresses to publicly registered IP addresses inside each IP packet. Notice that the router, performing NAT, changes the packet source IP address when the packet leaves the private organization. The router performing NAT also changes the destination address in each packet that is forwarded back into the private network. Static NAT. First, the concepts. The company's ISP has assigned it registered network 200.1.1.250. Therefore, the NAT router must make the private IP addresses look like they are in network 200.1.1.250. To do so, the NAT router changes the source IP addresses in the packets going from left to right in the figure. With static NAT, The NAT router simply configures a one-to-one mapping between the private address and the registered address. Supporting a second IP host with static NAT requires a second static one-to-one mapping using a second IP address in the public address range. The enterprise has a single registered Class C network. It can support at most 254 private IP addresses with NAT. The terminology used with NAT, particularly with configuration, can be a little confusing. Cisco uses the term inside local for the private IP addresses in this example and inside global for the public IP addresses. Using NAT terminology, the enterprise network that uses private addresses, and therefore needs NAT, is the inside part of the network. The Internet side of the NAT function is the outside part of the network. Cisco calls the private IP address used in the inside network the inside local address and the address used to represent the host to the rest of the Internet the inside global address. Dynamic NAT. Dynamic NAT has some similarities and differences compared to static NAT. The mapping of an inside local address to an inside global address happens dynamically. Dynamic NAT sets up a pool of possible inside global addresses and defines matching criteria to determine which inside local IP addresses should be translated with NAT. The dynamic entry stays in the table as long as traffic flows occasionally. You can configure a timeout value that defines how long the router should wait, having not translated any packets with that address, before removing the dynamic entry. You can also manually clear the dynamic entries from the table using the command clear IP NAT translation *. NAT can be configured with more IP addresses in the inside local address list than in the inside global address pool. The router allocates addresses from the pool until all are allocated. If a new packet arrives from yet another inside host, and it needs a NAT entry, but all the pooled IP addresses are in use, the router simply discards the packet. The inside global pool of addresses needs to be as large as the maximum number of concurrent hosts that need to use the Internet at the same time, unless you use PAT. Overloading NAT with PAT or port address translation. Some networks need to have most, if not all, IP hosts reach the Internet. If that network uses private IP addresses, the NAT router needs a very large set of registered IP addresses. With static and dynamic NAT, for each private IP host that needs Internet access, you need a publicly registered IP address, failing to reduce address consumption. The NAT overload feature, also called port address translation, PAT, solves this problem. Overloading allows NAT to scale to support many clients with only a few public IP addresses. The key to understanding how overloading works is to recall how hosts use TCP and User Datagram Protocol, UDP, ports. NAT overload translates not only the address, but the port number when necessary, making what looks like many TCP or UDP flows from different hosts look like the same number of flows from one host. When PAT creates the dynamic mapping, it selects not only an inside global IP address but also a unique port number to use with that address. The NAT router keeps a NAT table entry for every unique combination of inside local IP address and port, with translation to the inside global address and a unique port number associated with the inside global address. And because the port number field has 16 bits, NAT overload can use more than 65,000 port numbers. PAT is by far the most popular option. Static NAT and dynamic NAT both require a one-to-one mapping from the inside local to the inside global address.